Let's get back to work.
The main characteristic of transistors, whether they are bipolar, field effect, unijunction, or any other type of transistor, is that they can be used as a high-speed switch or as an amplifier. We are now going to do another practical activity that will illustrate how transistors can be used as a touch switch and also as a small signal amplifier. We will use two small signal bipolar NPN silicon transistors in this activity to achieve this. Build a circuit with NPN transistors used as a switch and simple amplifier. Refer to your workbook for the detailed instruction on constructing the circuit. If you want to use the touch switch to drive heavier loads, for example lights or motors, then you can include a relay in the circuit. Connect the relay in series with the collector of transistor 2 and then use its contact points to switch the load. Note that you will have to increase the supply voltage to activate the relay coil. You could also use a buzzer instead of the LED to create a simple touch-type doorbell. The circuit diagram indicates how you can include a relay or a buzzer in the circuit. We will now watch a video demonstrating how this activity could have been done.
Today we wish to demonstrate the use of a transistor as a switch. As you are aware, a transistor can be used as a switch or as an amplifier. In this video, we will demonstrate how the transistor is used as a switch. Okay, so this is the circuit that we're going to be using in order to construct our switch, and we want to get a little bit fancy and make it a touch controlled switch. What do we need? We need two transistors, BC547 or equivalent. You could use a BC337. Same here. Resistor to limit the current flow to my LED, 330 ohms or anything close by, and a 100k ohm resistor. We are now going to put all of this, and obviously a 9-volt battery. We're going to put all of this using this diagram. We're going to connect all of that on the breadboard as we have learned already. Now I'm going to deliberately keep the components a little far apart so that you can see how it is connected. If you look at the data book and data sheet as per the PowerPoint presentation, you will see that that is the emitter, that is the base, and that is the collector. It's the same for the other transistor. So I'm going to place that on my breadboard. Notice each pin is occupying its own 5-volt section, so they are not touching each other. I want to put this one a little further away so that we can see exactly how this is being connected. Now, let's call this transistor 1, let's call this transistor 2. This is transistor 1, there's it there, transistor 2. The emitter of transistor 1 is connected to the base of transistor 2. Let's do that. The emitter of transistor 1 is connected to the base of transistor 2. Okay. So we've done that. The emitter of transistor 2 goes to the negative supply rail. So let's use blue once again. The emitter, here's the emitter of transistor 2 is now going to go to our negative supply rail. Now you can see the beauty of the breadboard and having understood all these various input points. So I've done that. Always work methodically so you don't leave anything out. The LED anode is connected to the plus of my supply rail. So there is my LED, We've learned earlier on that the long one, the long lead, is my anode. Let's just put it somewhere else, like so. Always like it facing on one end. So the anode is connected to my positive supply rail. So there's my anode connected to my positive supply rail, like so. My cathode is then connected to a 330 ohm resistor. If you know your color code, you will pick the correct one. Have a look here. So there's my cathode. That top end is the anode. So I'm going to connect my resistor. I can come up that way, or I can go this way. Let's join it here and come back on this side. Like that. That is then the other end of the resistor is then joined to the collector of transistor 2. So we're not going to make it there, so let's bring this resistor here into a neutral place. Okay, so the other end of the resistor that's here is connected to the collector of transistor 2, and we have identified that as being transistor 2 emitter base collector, like so. Just double check our work. All that is now complete up to that point. From our anode, we're now going to join a 100K resistor. This is a 100K resistor. So from our anode, that's why it's always important to have the anode facing in one direction, so you know exactly where it is. You don't have to pull the LED out again. So I'm just going to go there and go to a neutral point, like so. So my 100K resistor is connected to my anode, and the other end of that resistor is connected to the collector of transistor number 1. If you know your breadboard well, this will go well. Here we are. Now for our touch points, we're looking at transistor number 1. The first touch point is going to be on the collector of transistor 1. So that's emitter, that's base, that's collector. So let's just go to the collector. Let's go to a neutral point. The other touch point is on the base. Please ensure that these don't touch. Sometimes you can make a mistake and put it on the same 5 input rail. And now we need to power the circuit up. Go to our power supply rail plus, power supply rail minus, touch. Anywhere that you see touch controls, ATMs, etc., that is how a transistor works as a switch.
End of Module 2.